Good. All right, here we go. 5.5, here we go. You checking? A was just getting the tangent line, right? They just simplified. Yeah. They just moved it to the other side. You guys could have done y minus 5 equals negative 4/5 x plus 4. They just added the 5 on the other side. Remember, get the tangent line alone. Then they plugged in negative 3.9 to the function, plugged in negative 3.9 to the line, and compared the two. Not too bad. Well, they were saying what the error is, and they're like, oh, the error is less than, just check it out, right? Tenths, hundredths, thousandths, it's less than 1,000. That's all they did. They just did scientific notation. Less than 1,000th. Number 8, there's the tangent line if you're still checking number 2. Okay, the function value, they're trying to have you look at 1.002 to the 100th, but obviously we can't do that in our heads, and we don't want to. 100th power, no. So then they were approximating. How are they approximating? What'd they use?
Well, they gave us a formula in the direction.
Right, 1 plus
x to the k, and then approximated to 1 plus kx.
Oh, did they actually do the derivative for you? Right? How do you find your tangent line? Because then the one that you know is when k is 0, right? I would have done the point of tangency at 0. And so then f of 0 is just 1, so I would have added 1 to the other side. F prime would be 100 times 1 plus k, which is point of tangency 0 to the 99th. K minus 0. You just want to make a tangent line. And the derivative, you would bring down the 100, make it the 99th power times u prime is just 1. Plug in 0, your point of tangency. Plug in 0, your point of tangency. Plug in f of 0, your point of tangency. And so this is just what they did after. What they did after they went ahead and solved. Simplify it, because then they want you to actually use this to plug in 0.002, right? So you have 1 plus 1 to any power is still 1, so that's 100, and then you have your 0.002 minus. They just wanted you to solve. So then 100 times, wouldn't that be 1.2? Which is L of x, which is approximately 1.02002. So the answer is 1.2 is a linear approximation for the function value, 1.002 to the 100th. Does that make sense? Oh, sorry, they also talked about the error, but once again, the error is less than 1/10 because it moves into the 100th spot, if you actually solved it. Letter B, yeah, just do it the way that we did it yesterday with the tangent line. Answer is 1.003, which if you compare to the actual, they said is less than, tenths, hundredths, thousandths, 10,000ths, 100,000ths, less than 100,000th off. Justin.
So back to A.
Sorry.
When you get the exponent at 99, bring it down, what do you do with the 99?
You're doing the point of tangency, which is one that we know, 0. So it ends up just being 1 to the 99th. Which is still just 1. So I dealt with the 99th power, just 1 to that 99th power was just, and hence why the 100 is all that's left. Yeah. Number 14. Once again, another tangent line, right? Take the derivative, plug in 81. Guys, I don't mind if you stop with the 9 minus 1 over 18. They're probably not going to make you get decimals by hand on the AP, but 9 minus 1/18 would be the proper approximation. But yes, it is 8.94949. Number 22 is a differential. They left it implicit, thank goodness, because getting y by itself, it's possible. I'm actually surprised they left it implicit, because you could add and you could factor and divide and plug in.
No, that's so hard.
Just kidding, leave it implicit. I'm just saying you could have. You could have. That's all I'm saying. And letter B just says plug it in, plug it in. They give you the delta x, how far off, right? And they give you the x and the y, so you're able to plug it all in. Number 26, you had to review your boolumbu. But that's it. And then, yeah, that's where it got nasty, right? Is that our last one? Good. That's the whole propagation type of thing, right? Oh, 62. 62 is A. Okay, number 44, I have my book open somewhere. I'm guessing no one wants to take number 44 for a homework problem, hence why I'm going for it. What page is this homework on? Come on. 44 is probably the next page, though, huh? Okay. If I want. Okay. If you guys check out the answer key real fast, as far as what they use, because you had to make your own equation for this. We know that the volume of a cube is s cubed. They went ahead and used x cubed. That kind of makes sense, right? So when they were plugging in, trying to think of, let me go back to, there we go. Coming back to the problem at hand, they went ahead and said, okay, volume of a cube, v equals x cubed. We can say dv is equal to 3x squared dx. And we can say that dv is approximately delta v, how far off the volume measurement is based on your edge measurement is what's kind of going on. They tell me with an error of 1%, you can think of it as plus or minus 0.01 as far as how far off. But when they talk about percentage, you can actually think about percentage error as a ratio. And so we could say that delta V over V percentage, so that off the volume is with regards to the actual volume, part per whole, how far off with regard to the whole. We could say that that is, well, we could actually solve, but the solving part is going to be tricky because then we'd actually have to put into the x cubed. We're going to use the dv to help us out. And so dv is 3 times who squared? 3 times, what do we get the edge to be, 10? Yeah. And then how far off could it be? Plus or minus 0.01. Now wait a minute. Plus or minus 0.01, that's the percentage. How actual far off would it be? Yeah, have to figure out what that not a lot is. Yeah, we could find 1% of 10. Isn't 1% of 10 1/100th of 10? Isn't that the same thing? Yeah, so we could just make it 1/10. So 0.1, yeah. So that's how, because we're trying to think centimeters, right? So we have centimeters squared there. Now we have centimeters here, not percentage, but the actual measurement, how far off 1% is of 10 centimeters. And then the volume itself, wouldn't that be 10 cubed? See what I mean? So we had to plug in the volume itself. So x cubed, and then 3x squared dx. 30 divided by 1,000, right? So 3 over 100, so 0.03. Which would be error of, that's what I got, but let's double check that that's the actual. What did they say? Ah, got it. So delta V is approximately dV, and then volume is x cubed to plug in. Is that okay, kind of? Okay, so number 45, Riley, that was you, yeah? Oh, Maggie, we kept on going. Side of a square, we're going to call the square an x again. So area formula. a equals x squared. So dA is equal to 2x dx. Within 2%, that means the error is plus or minus 2%, right? So from this, we could say that the delta A over A is approximately dA over A. Didn't help that time. There we go. Which is 2x dx all over. So what am I going to fill in for area? Formula. Just x squared. Does that make sense? So like we did, volume up above was x cubed. Area down below, x squared. And then they told me what that needs to be, right? 2%? To be honest, when I'm solving things, I do not like decimals. I'm going to put 200ths. It's a lot. The x's go ahead and reduce. What do they want me to solve for? How accurately? They want me to figure out the possible error. That's what they want me to solve for. To be sure of calculating the area to within 2% of its true value. What am I missing? Oh. Sorry. 2% of its true value. No, that means that dA is equal to 2%. Right? They want the area to be within 2% of its true value. How far off the area is 2% of its true value. Sorry, I interpreted it wrong. I translated it wrong. If anybody wants to weigh in, I would totally be opposed. I mean, you could say less than 2% of A and greater than 2% of A, negative 2% of A. That's the idea of the plus or minus. I have the same problem. So it's going to be 0.2%. Percentage error, and I still agree with this. I don't think that's wrong. We have two variables left over. Yeah. Oh, percentage error. Duh. Okay, that's my bad. Sorry, guys. If you multiply by 1/2, your x's do reduce. I had it. I just didn't realize I had it. You end up with dx over x. What's that? Percentage error of the measured side. We had it. I was looking for dx, but dx is the measurement error. We're not looking for measurement error. They didn't tell me like how accurate your tools need to be. So I got stuck on like, oh, plus or minus centimeters. They didn't care about that. What they were looking for was the percentage error, which percentage error of area, dA over A, percentage error of side, dx over x. So yeah. Staring me in the face. I got confused by it. There you go. They're looking for percentage error. Okay. We have now graded all the evens on, 62. I didn't stay there very long, if anybody wanted to look at it. All the evens on section 5.4 and 5.5. But you guys had some questions on 5.4. So number 27, I gave you the formula to in Google Classroom. Maybe some of you need to pull out your phone and check that out if you didn't last night like you were supposed to. But what other questions do we have? Let me go back to that homework so we can circle. There he is. He looks so nice and short and easy, huh? All right, where we get stuck? 45. Number 2. What else? 45 whole thing. 26. Oh wait, Hannah. 26 isn't up there. 27. Oh, I don't know how to do that one. I mean, I can peek at it for you, but they wouldn't have it. 5.
23. I can do 5.
Keep peeking. All right, as people get looking, as you come up to the boards, erase whatever's there, and you're going to take over showing me your work. You don't have to write out the problem. They should have that in their book. Just go with solving. Who wants number 2? Come on down, Kathy. Who wants number 5? Maggie, come on down. Who wants number 23?
I can do 23.
It's okay. We'll get somebody. Just erase the boards wherever you go. Bye. Number 45? Oh, you want 23? Yeah, come take it, Daniel. Number 45. Number 50? Whoa. Where are my superstars? Come on. Okay, who can show me where they got stuck on any of the above 3 mentioned? Oh, I knew, but you already have one. James, what do you want? Take it. I like it. Why don't you take the sideboard, because then I'm going to need some space. Who got stuck on 50? Like, actually got there and got stuck. Well, you're the one awkwardly sitting there. Justin, can you show me what you got on 50? Why is it so weird? What's going on? Okay. So this is the price, the cost. So cost would equal N times C, right?
Wait, why is it time?
Because this is just how many. So how many you make times how much it costs.
Okay.
Does that make sense? Mm-hmm. That's going to be cost.
Oh, when you
and then profit.
Why is it X?
Who's X? N is number. C is dollar. I don't think you wrote down what X is. X must be selling price. No? Yeah, that makes sense. Selling price minus cost times the N would be the profit. Okay. There you go. Then plug in your functions, take your derivative of critical numbers.
Wait, so once I get this, when I take the derivative of it?
Plug in your function for N. Then take the derivative of that plugged in.
How can I take the derivative if it's like more than 1?
Because C is a constant. Because that's an established beginning. Yeah, does that make sense? Okay. Why don't you pull out that board? Take it away. There you go. Okay. As they're working on your guys' homework questions, okay. Oh, you guys can't see it. Hold on. What can I do? Okay. Here's the dealio. You guys aren't up at the boards right now. Boards, you guys work on notes. And when they sit down, what theoretically could you be doing? Working on the boards exactly as they work on notes. Meaning you could be looking, you could be checking, you could be taking pictures, etc. Are we good with that? So your guys' job right now, notes. Implicit differentiation, leave me like a line or two. Yeah, Sally, what's up? Yeah. I'm going to pause right now because they're just... If you didn't do your homework, you shouldn't be talking. Okay. Maggie. What were the equations in number 27?
200x for the interval x equals to
Well, I figured you wrote it down since you were asking about it. Is that okay?
yeah, and then it's 200 minus x minus 50 times 2, and then all of it will have x, yeah, and then the interval is 50 is less than 2.
I got it, don't worry. And this was the cost?
That one?
No, it's how much it charged for the group, right?
Yeah. But then they gave some weird they gave an equation in the problem too, so I was so confused.
Cost is equal to...
I think it's 600 plus 30.
Oh, I was just naming it X, sorry. So then profit is equal to, this is the, M of X for money. I don't know what else to call it. So then it's the money coming in minus the cost going out. So then I can go P prime, which is going to be to find your profit, the critical numbers, is M prime minus C prime, which I'm disregarding the endpoint. We could regard the endpoint, but the derivative is 200, which will never be 0. So forget that critical number. This guy, I think I rewrote him. Did you get that down, what the rewriting would be? It's okay, I got it. So negative 2x, that'd be negative 2x squared. That'd be negative 100 plus 100, 300, 300x. If anybody could check my mental math, that would be great. M prime would be negative 4x plus 300 minus C prime would be 32, which would be negative 4x plus 268, which would happen at x equals 268 over 4, which would be 67. There we go. So you just had to think about, this is how much money they're getting from the group. This is how much money the group is costing them. The profit is subtracting the money coming in minus the money going out, like Daniel showed for number 23. Taking the derivative of the function, critical numbering it. And of course, we could, once again, do a sign chart between 80 and 50. With our 67, we're going to have a max. Okay? Oh, I derived them.
Oh, yeah. Oh, you simplified and then you derived.
Yeah, sorry. I was just simplifying because I didn't want to take the derivative of that. Ugh. I mean, I could have. I just didn't want to. Yes. Well, it said a fixed rate, a flat cost of 600 and then 32 per person in the group. I think that one was pretty straightforward. This one was for a group size of 50, $200 per person. And for each person over 50, you get a $2 reduction in the price of each person.
So,
Yeah. Which ultimately on the test, my goal is not to make you do mental gymnastics in order to attack each problem. It's more, can you do the math involved? However, you have to realize there might be some translating that's involved. Now, the one that James is working on, the distance between the two springs, the hard part was a lot of you guys hear distance, give me just 30 seconds, and you think the distance formula, but those weren't points on a graph. They told you position of 1 is S1, position 2 is S2. The distance is just subtracting the two distances, or the two positions, taking the derivative critical numbers. He got against this nasty quadratic function with trig, and so, yeah, it's a quadratic. So I'm going to go over there and finish it up. I'm going to post a picture in Google Classroom. You guys are going to play with related rates a little bit tonight. Sound good? Okay. Tomorrow class, we'll go over examples, related rates, and see how you guys are doing. There is a test coming Friday. Please don't forget. I love you all. Sorry to shut you up, but I had to finish class. Bye, guys. See you later.